Hi friends, I am Chandrasekhar, Suvarna Career Academy, Bijapur. Friends, we have posted three videos related to the ISRO achievements, etc. And you requested us to post a video which will differentiate between the PSLV and GSLV. So it is very important. This is a very small video, but it will give a clear picture. It will differentiate how a PSLV is different from a GSLV. So only that topic is covered here. So for the achievements and all other topics, you can watch our other video. So this particular video is to differentiate the PSLV and GSLV. Okay. So we will see the key takeaways from this session. So that is very important, because what is the purpose of this session? It is only to differentiate PSLV and GSLV and different types of objects. Achievements and all other topics are covered in other three videos that you can watch. Okay. So the key takeaways from this session are, you will be able, after watching this session, you will be able to differentiate three types of orbits. Okay. And you will understand the PSLV, you will understand the GSLV, and you will be able to differentiate the PSLV and GSLV and application of PSLV and GSLV. These are the key takeaways from this session. This is a very small session, very important session. See, this is very helpful for the general studies paper for general studies paper for the prelims UPSC exam. Also, this is very important for, it is very helpful for the general studies for the mains also. So please watch this, kindly understand the concept how PSLV and GSLV are different. Okay, let's see our Suvarna Career Academy is in Bijapur, Karnataka. We provide the coaching and training for the UPSC aspirants. Let us see there are main three types of orbits are there. Let us see what they are. First one is the polar orbit. So first, before going into PSLV and GSLV, we will understand what is a polar orbit, what is a geostationary orbit, what is a geosynchronous orbit. So try to understand these three orbits. Okay, first we will see what is a polar orbit. Orbit is the one in which the satellite rotates. Okay, either maybe like this, maybe like this, or maybe like this. Okay, that is, along the orbit the satellite will rotates. Okay, so it is very important to understand the what is a orbit and what are the types of orbits. See, first one is the polar orbit. See, polar orbit, see, this is the earth. The polar orbit will be like this. It will be, sorry, the polar orbit means this is the north pole. Please try to understand what is a polar orbit. Okay, see, this is the north pole, this is the south pole. Okay, this is the equator. See, this is the equator, right? So the polar orbit will be like this. The polar orbit, 1 minute, the polar, it will be along the pole. Okay, like this. Okay, means it will be like this. This is the earth. If this is the north pole and this is south pole, it will be like this. This is the polar orbit. Polar orbit. Okay, so understood the polar orbit. Okay, I'll draw it once again. See, this is the north pole, this is the south pole. It will be like this along the pole. Okay, again it will go to that side and it will come like this. Okay, this is the polar orbit. See, in the polar orbit the satellite will rotate like this. That means it will not look stationary when we view from our place. It will not be fixed because it will go like this. Okay, that is the polar orbit. So understood the polar orbit. Okay, so this is just an equator I draw. So the polar orbit is 90 degree to the equator. So the polar orbit, Okay, so try to understand these three orbits. First one is the polar, second one is the geostationary, third one is the geosynchronous. Okay, polar you understood now. Now we will move to the geostationary orbit. It will be along the equator like this. It will go like this and again it will come like this, then it will come like this. This is the geostationary orbit. That means it is 0 degree to the equatorial area. Okay, I will draw once again to make you clear the geostationary orbit. Okay, it will be like this. It will come like this and it will go like this. Okay, that is 0 degree to the earth equator. Okay, see, this is polar orbit, is 90 degree to the equatorial region. This is polar geostationary orbit. See, in the geostationary orbit, the speed of the angular velocity of the if this is the earth, assume that this is earth and this satellite, the speed, the angular velocity of this earth and this satellite will be same. So because of this, the satellite will be looks like as if it is stationary. The satellite looks like as if it is stationary. I will draw once again this geostationary orbit. This will be 0 degree to the equatorial region. Okay, it will be, if this is the earth, then it will be 0 degree to the equatorial region. So it makes 0 degree, and here the satellite will look stationary. Okay, then here it will not look stationary. And the third one is the geosynchronous orbit. Here it will be, the axis will be inclined. It will be like this. Okay, it will be inclined to the equatorial region. See, first one is polar orbit. It is perpendicular to the equatorial region and it will go around the poles. Okay, and geostationary, it will be parallel to the equatorial region, and geosynchronous, it will be inclined. Okay, only in the second case the satellite will look stationary because the angular velocity of the earth and the angular velocity of the this satellite will be same. Okay, so you understood these three: polar orbit, geostationary orbit and geosynchronous orbit. I hope you understood this. Okay, so next one is the PSLV and GSLV. Now we have come to the PSLV and GSLV. See, the launch vehicle, the rocket which carries the satellite and puts in the polar orbit is called as the polar launch satellite vehicle. See, satellite vehicle is common for both. Okay, only this polar PSLV will put the satellite in the polar. What PSLV will do, it will put the PSLV means it is a launch vehicle, it is a rocket. What it will do, it will put the satellite in the polar axis. That means PSLV, if this is the earth, then if we launch PSLV, it will put the satellite in the polar axis like this. Okay, polar orbit, polar, it will put the PSLV in the polar orbit. This is the PSLV. And the GSLV will put, GSLV is also a launch vehicle, it will put the rocket in the synchronous, it will put in the synchronous orbit. So I hope you understood the polar orbit and synchronous orbit. See, PSLV will put the satellite in the polar orbit and the GSLV will put in the geosynchronous orbit. So the long form of the PSLV is Polar Satellite Launch Vehicle and GSLV is Geosynchronous Satellite Launch Vehicle. Okay, I hope you understood PSLV and GSLV. See, the PSLV is 4 stage. The PSLV is 4 stage. That is solid, liquid, fuel. I am telling it is a first there will be solid fuel, then liquid fuel, again solid fuel, again liquid fuel. It is a 4-stage. Okay, it is a 4-stage. Whereas GSLV is a 3-stage. First solid, then liquid, then cryogenic. Okay, so the geosynchronous is a GSLV is 3-stage. So try to understand. So cryogenic is used for GSLV. Okay. Now for application, where this PSLV is used, the PSLV is used for the remote sensing, earth monitoring. That means PSLV means if India launches a PSLV, then in the daytime that satellite should come on India, the India area, because it should capture the earth pictures, remote sensing, etc. And GSLV is for communication satellites. Communication satellites. Dear friends, I hope you are clear with the topic. So it is a very small topic. So I cleared the different types of the orbits, PSLV and GSLV, stages, etc. And application also I have covered. Now we will see two questions, MCQs we will see, and so that we can answer the questions. Okay, let us see. Okay, the question is, which of the below statements are correct? 1. GSLV is a 4-stage launch vehicle. PSLV is a 3-stage launch vehicle. Just now we have seen GSLV is a 3-stage launch vehicle. So this statement is wrong. And PSLV is a 3-stage launch vehicle. No, this statement is also wrong. So both the statements are wrong. So the answer will be D is the answer here. So D is the answer here. Okay. So now we will move to the next question. Next question, this was asked for the UPSC exam. Let us see. With reference to the Indian satellite launch vehicle, consider the following statements. Okay, which statements are correct, he is asking. Okay, let us see first statement. PSLV launch satellites are useful for the earth resources monitoring, whereas GSLVs are designed mainly to launch the communication satellites. Just now I have told this. This statement is very correct. Okay. The satellite launched by PSLV appear to remain permanently fixed in the same position in sky as viewed from a particular location on earth. Just now I have told PSLV it will not look stationary. Okay. So this statement is wrong. So in geostationary it will look fixed. At that time this statement will be correct. Geosynchronous also it will not be correct. So this second statement is wrong. GSLV Mark III is a 4-stage launch vehicle with first and third stage using solid rocket and second and fourth are using the liquid rocket. This statement is 3 because GSLV is a 3-stage. So only statement 1 is correct here. Okay, that means this is the correct answer. Okay, so let us see the key takeaways. We'll be able to differentiate the 3 different types of orbits. One is the polar orbit, this is the earth, north pole, south pole, polar orbit, then geostationary orbit, geosynchronous orbit. You will be able to differentiate. Polar orbit means it is perpendicular to the equatorial area. This is polar orbit. Geostationary orbit, geosynchronous orbit. Okay, understand PSLV and GSLV. The launch vehicle which will put the satellite in the polar orbit is called PSLV, which will put in the synchronous object is called GSLV. So 4-stage for PSLV and 3-stage for the GSLV, you understood. And the application also I have told it clearly. For PSLV is usually used for the remote sensing and earth imaging, and GSLV is useful for it is used as a communication satellite. Okay, very good. Kindly go through this video 2 times so that you will remember these things. Okay, thank you very much.